This video is about specific autoencoders and applications. We will talk shortly about convolutional autoencoders and see different applications. For the application of neural networks to supervised learning tasks, we had seen that convolutions and convolutional neural networks had advantages when processing images. Now we can ask if we can use convolutions in adversarial in autoencoders as well. Now we can ask if we can use convolutions in autoencoders as well, and of course we can, since autoencoders are just neural networks where we have the same kind of input and output. And this gives rise to so-called convolutional autoencoders. And since we usually reduce the number of dimensions in the encoder, we need to use decoders, which consists out of transposed convolutions or simple upsampling operations. So we could have the following convolutional autoencoder, where we have an input and convolutional layers to produce our encoding here. And then we would need upsampling operations to come back to the same size as our input dimension was. And small experiments where we again have noisy data, which we aim at denoising and reconstructing, and we see the results of a standard autoencoder with only 32 hidden neurons. There the reconstructions are a little bit blurry. And here we see the results of a convolutional autoencoder which has much fewer parameters compared to the standard autoencoder, but leads to much better results. So this is the last row shows the original data. So we see that the convolutional autoencoder almost produces a perfect reconstruction. So this tells us or demonstrates that convolutions are, of course, again, advantage when we use image data. We can use autoencoders in several real-world applications. We can use them, as demonstrated in this example, for data denoising. We can use them for compression and also for very heavy compression, namely for dimensionality reduction for the purpose of visualization. And here we see an example of an application in image denoising with a convolutional autoencoder in the medical domain, where we might get noisy versions of an image shown here. And this would be the clean image. And we would like to denoise that. And here we see the results of noising autoencoder, which are a bit lighter than the original input, but the noise is removed. And the last row shows an alternative, some kind of filter that aims at noise reduction, but this is clearly not as good as the results of the convolutional autoencoder. And then we could use it, for example, for image compression. So we see here different compressed versions of images, and here's results in the first column of a convolutional autoencoder compared to some JPEG result here. So it gets similar good results.